First bad version. You are a product manager and currently leading a team to develop a new product. Unfortunately, the latest version of your product fails the quality check since each version is developed based on the previous version. All the versions after a bad version are also bad. Suppose you have an version like version 1, version 2, version 3, and then version end, and you want to find out the first bad one which causes all the following ones to be bad. You are given an API boolean functions is bad version, and then we need to pass the integer value version, which returns whether version is bad or not. Implements a function to find the first bad version. You should minimize the numbers of calls to the APIs. So if the version, if we have 5 versions and then the bad version is 4 at the time, the version 5 is also bad, right? Okay, so there's a lot of approach to solve this problem. We can, because they have the constraint, the version will start from 1, right? So we can start from the very first version, and then we will check which version is bad, right? We will check the first version, and then second version, third version, fourth version, and then when we get the true, until we get the true values from this function, and then we will check from the start, right? The first approach is. Then second approach is we will start from the back. If we have 5 versions, we will look the latest version first. If it is bad, we will keep looking to the previous version. If the previous version is also bad, we will keep looking for another one. And then if we found the previous version is not bad, at the time we think, okay, this one is the first bad version, right? So okay, we have 2 approach. And then the latest approach is because they want us to minimize the numbers of call to the API, I text this problem before I make this video, and then at the time when I go from the first version to the end, at the time I got time execution error. Until we can solve all the test cases, we pass every test cases, but it is time executed. So we need to minimize the numbers of call to the API. And then when I go from the back to the first version, and then it was okay, but now it's not kind of different, faster than the other solution. So I will go with the latest strategy, a latest approach. Instead of going from the start, going from the back, and then I will go with 2 pointers version. It's like a binary search, because okay, for example, if we have 1, 2, 3, 4, 5 versions, and then if we will just divide, okay, we will just divide it 1, 2, and then the another one is 4 and 5, right? So at the time mid value is 3. At the time we will check that 3 is bad version or not. If it is not bad, we will check only the second half. We don't have to check this one because this one is already good, right? So we don't have to check this one is also this one is bad or not. So we can reduce half of our time complexity, right? So we can go that way. And then if we are looking for this one, and then if the middle value is good, we will add to our start value. For example, if the start value is if it is starting 0, we will change the start value with mid plus 1. So start value is gonna be 4, right? 4, and then gonna be 5. At the time when we are looking at the 4 and 5, and the middle is 4, right? Middle is 4. If the middle 4, when we check the version, if it is true, we get the first bad version, right? Okay, let's do this. I will have to create start. So sorry. I'm sorry. and then end value is gonna be n, right, because we have n version. And then while, because we moved the stat and n, right, stat and is less than and what we are gonna do, we will get the media value, and then we will find the media value by using this one, because you know I because we can look for the media value stack flags and like this, stack plus and bind to, right? Why I'm doing this way, you can check in the Google's what they are different, because they can have, this one can have integer overflow or operation overflow, you know. This one is not good for the very large amount of array or something, or very large amount of integers, I mean not array, so sorry, yeah, you know. But if the integer is really big, at the time when we are doing this way, we can get the integer overflow or operation overflow error. So is the best way to look for the middle values. Okay, and then if we got the middle value, okay, we got the middle value, so we will check by calling this API function and then mid value. Okay, hey, this one is bad. Oh really? So at the time we will move the end value, right, middle value. If it is not, we will move the start value. So when we when the start and end are, when the start is not less than and anymore, at the time the one we want is will be at the end value, right? Okay, so end, okay, right? Okay, so for instance, if we have 1 2 3 4 and 5, and then the version is 2, at the time we will check 3, and then if 3 is what about and then that's gonna be like, because I just start 0 and then end is and 5, right? And then media value is 1 2 0 1 2 2, right? So media is 3 now. For now I'm not saying the index, I'm just saying the version number. Okay, so 3, at the time 3 is bad version, no, because this one is 3 will be true, right? Because if the bad version is true, everyone's behind that is bad version, right? Everything's okay. So if the 3 is true, yes, and gonna be media value. Okay, so stat is just 0, and then and it's gonna be 3. Okay, we will look for this one, and then and then when we are checking this one, and then we got 2, right? This one, if it is true, if it is mid version, and then and it's gonna be 2, right? And then when we are checking again, 1, if it is 1, that's gonna be 3, right? At that time stack value is greater than end value, so they will stop looping, and then the result we want is at end value. Okay, so let's submit this one. Let's run this code. Okay, so I'm gonna submit this one to see what will happen. Okay, cool, so that's it. Thank you.